All right, so next up, we are moving into the methods portion of our reproducible research competition in the open track division. First up, we have Ryan Brill. So Ryan Brill is a fifth and final year PhD student at the University of Pennsylvania. I guess that's true. The okay. There it is. The curse is gone. So as the fifth and final year PhD student, this means he has survived the PhD. Mentioning it's with Larry from before. So he's reached the ending point. And what he's going to talk about today is his new work on the NFL draft and the NFL draft curves. Ryan is famous for tackling problems people have looked at in the past that they've had accepted beliefs about, and he's approached them in ways that say, no, I think you're kind of wrong. And so I think we're going to be told we're wrong again today. All right, so let's turn it over to Ryan. Take it away.
Sorry? This is good. Is there a laser on this one?
Yep.
Thanks, Ron. Okay, hi. Today we are going to talk about the NFL draft. Okay, so trading draft picks is a big part of football, right? When the 49ers traded a massive haul of picks for the third overall pick in 2021, or when the Panthers did a similar thing in 2023, how did those teams decide that those were good trades for them? So the story of sort of draft trade chart math begins in the late 80s, early 90s with the Dallas Cowboys. Vice President Mike McCoy created the Jimmy Johnson draft value chart. Jimmy Johnson was the coach, which assigned a numerical value to each draft position, and a trade was considered fair if the sum of the numerical values on both sides of the trade were equal. But they kind of created that draft chart based on just gut instinct and kind of ad hoc looking at past trades. So more recently, about a decade ago, Massey and Thaler created a more rigorous data-driven draft value curve, and they found a couple interesting things. One is known as the loser's curse, that the very top picks aren't as economically valuable as later picks, and we'll be more explicit about that in a sec. And also that draft capital is traded suboptimally. So we're going to revisit their analysis today. And so we are interested in estimating and defining the value of a draft position X from 1 to 256. To do so, we are going to need an outcome variable Y, which sort of says, once a player is drafted, how good was he in the NFL, and what does good mean? So you want the value of a player's performance, and we want to measure performance of players of all positions on the same scale. So you want to be able to compare like linebacker performance to quarterback performance. So the two, I mean, there are a few ways to do this. One way is like wins above replacement. People commonly use salary. So we're just going to use the second contract salary relative to the salary cap as the outcome. And then traditional draft curves are all of the form, basically the expected performance value given draft position. Okay, so in other words, 4 players drafted at pick X, on average, how good were they? Or on average, what was their second contract salary relative to the cap? So let's visualize some of these curves, starting with the blue curve, which is the expected performance curve. So for all these curves, the value of the first pick is 1. We're looking at value relative to the first pick. And on the blue curve, when you see that, for example, the value of the 65th pick is 0.3, what that's sort of saying is, among players drafted at pick 65, on average, their performance or their second contract salary relative to the cap is 30% of the first pick. Okay, so that's the blue curve. The red curve is cost. So, all right, our outcome variable right now is second contract salary, which is signed in free agency after the first contract is over. So it's a reflection of how good they were during their first contract, right? But players during their first contract are paid cheaply because it's a rookie contract. They're paid less. So the amount that they're paid in their first contract is the red curve, or the cost, which you can see is steeper. So just a few picks, even after the top pick, the cost of those players goes way down, way down, way down, and then it kind of levels off. This is sort of a minimum wage right here. Okay, so in general, the performance of players in their first contract is above their cost. So there's sort of a surplus, which is performance minus cost, also known as surplus. So if you look at the expected surplus value, that's the green curve. So for example, looking at players drafted at pick 65, on average, how much surplus did they have relative to the first pick? That's about 0.7, let's say. So what you see here is this spike where surplus value, expected surplus value, goes above 1 during the first round. That is the loser's curse from Massey and Thaler's paper. So why is it a curse? Because the absolute worst teams who pick at the very top of the draft actually get less surplus value on average than better teams who pick later. And why is that? That's because these very early picks cost a lot relative to later picks, but the average performance value only declines a little bit. Okay, so that's the green curve. Then in pink, which is kind of hidden by the orange curve, in pink is the Jimmy Johnson curve, which we already talked about. And finally, this orange curve, also created in the Massey-Thaler paper, is basically, if you take the data set of all observed trades consisting solely of draft picks, and you asked which single draft value curve best fits the data of all observed trades, what would the curve look like? You get the orange curve. So in other words, how are general managers trading, or how are they valuing picks on average? That's what the orange curve is saying. And what you see is that the orange curve is much steeper than both the blue curve and the green curve. So the sort of implication of that from the Massey-Thaler paper is that if you think teams should be trading draft picks based on a blue or a green type curve, then they're trading horribly inefficiently, right? Or in other words, you should be trading down. So for example, in the market, according to the orange curve, you could trade number one overall pick for two, let's say, fifth overall picks. But the fifth overall pick, according to the blue curve, is worth like 0.8. So you're actually getting 1.6 according to the blue curve. Or according to the green curve, you're getting like 1.5 times 2, which is 3. So that's what they would say. So just to be very explicit, what are the implications of a traditional draft value analysis, which are expected performance or expected surplus value curves? Basically, there's a loser's curse in that top picks aren't as economically valuable as later picks, meaning in terms of surplus value, and that NFL general managers are trading suboptimally. They're not trading down often enough, and when they trade up, they're overpaying. Okay? So basically, last February, Cade Massey called me up and said, I want you to see if the analysis from 2013 replicates to modern data. So I took, the data set from 2013 to 2023, and I basically found that it completely replicates. And you can even look at different outcome variables other than second contract salary, and it still replicates. And what's interesting about that is their paper has been out for over a decade. A lot of people know about these results, but draft trading behavior basically hasn't changed at all. So why not, right? And Cade would probably tell you that the market is inefficient and maybe general managers are just really stubborn and they're not being very wise. But I was sort of wondering in the back of my head, is there some sound economic reason why general managers aren't using expected performance or expected surplus value to value a draft position, right? So this brings us to Brad Pitt, aka Billy Beane. What's the problem, right? The whole point of all this draft business is to win the Super Bowl. You want to win the Super Bowl, and to win the Super Bowl, you need to be the best team out of 32 teams, right? In other words, you need elite talent, not just average players, right? So to echo the words of Brad Pitt in Moneyball, right? There's elite players, there's solid starters, then there's 50 feet of crap, and then there's rounds 3 through 7. So, general managers, I suspected back in February are, okay, they just want elite players. Maybe that's what's behind all this. They don't care about average players. So, okay, how can we create a draft value curve that values eliteness? Okay, I think the most intuitive example of this is right tail probability, or given your draft position X, what is the probability that that player's performance Y exceeds a threshold? Okay, and here we're interested in a tail R of performance, not a quantile. So for example, this tail threshold here is defined also as a percentage of the salary cap. But in a concrete example would be, what's the probability you draft a player better than Russell Wilson, or better than Kirk Cousins, or better than Patrick Mahomes, right? So this sort of valuation measure is equivalent to the number of elite players that are expected to arise from this pick. And that's because the expected value of an indicator equals the probability. Okay, so in order to get this right tail probability, and I made a bunch of other interesting draft curves, which will be in the full paper. Basically, I wanted to get this full conditional density of performance given draft position. So I created this very cool beta regression Bayesian model that we're not going to get into. But okay, so let's visualize some of these curves. So here, the black dotted line is the expected performance value curve, which was that blue line from the very first graph. And the solid black line here is the fitted trade market curve. And these colorful lines are different right tail probability curves. So what you see is that as we increase the threshold of eliteness, which is to say, as you go sort of inward on these colorful lines, the draft value curve converges almost perfectly to the observed trade market curve. So what is the implication? Is that the way general managers are valuing draft positions on average is as if they are interested in the probability that a drafted player results in a second contract salary above 15%. In other words, the probability that a player becomes extremely elite. That's like a very high bar. I think only 10 or 20 players in the last decade have even eclipsed this threshold. Okay, so that's interesting. But what about surplus value, right? If you're an economist, you care about performance above cost. So this black dotted line is expected surplus value, which is similar to that green curve from the very first plot. And these colorful ones are, what's the probability that the surplus exceeds a threshold given draft position? And basically what you see is that the effect size of the loser's curse diminishes significantly. So this little peak right here is much smaller, and it also kind of shifts earlier in the draft. So that's interesting. And finally, you might say, well, quarterbacks, right? What about quarterbacks? Quarterbacks, they get paid the most by a lot. They have the most wins above replacement. So can we make a separate draft curve for quarterbacks and non-quarterbacks? So explicitly, what is the probability that surplus value exceeds a threshold given if you're a quarterback or not, and given your draft position? And okay, what's interesting here is that for quarterbacks, if you are interested in an elite quarterback, there is no loser's curse, right? It's kind of flat for a few picks and then it drops off. There is no notion of trading down and getting a better pick if you're interested in an elite quarterback. Now, if you're interested in a non-quarterback, they're actually even if you want a really elite non-quarterback, even if you want Aaron Donald, and you have the very top pick, maybe there's a little bit of value in trading slightly down. And the reason for that, I think, is that the very top picks are priced quite high. You have to pay the top few picks a lot of money, and that payment is regardless of position. So it's almost like those top picks are priced for quarterbacks. But if you're going to draft a non-quarterback, then you're going to have a smaller right tail, and it's not necessarily justified. The cost is not necessarily justified. So, okay, there's a lot of words. What is this takeaway of this talk? First of all, if you're looking for an elite quarterback, there's no loser's curse. If you're looking for elite talent, lower draft picks aren't worth much, and the high cost of draft pick is justified. And finally, I think that you should be trading draft picks based on some combination of eliteness and expected value. So, for example, if you're the Chiefs, you already have Mahomes, Kelsey, Chris Jones, you already have a lot of elite players, then maybe a solid starter level player is actually going to be very good for you. But if you are the Bears in 2023, you're going to need Caleb Williams.
All right, thank you. I think what we're going to do is we're just going to switch over now into the next talk. And then, folks will be able to ask Ryan questions afterwards. All right, so thank you, Ryan. And next up,